But next, I would like to give the floor to Dr. JP to dive deep on cardiac uses.
Can you all see my screen? Is that okay?
Looks great.
Okay, awesome. Thank you, RSNA SIG, for giving me the opportunity to talk about our virtual reality program at Nationwide Children's, and it's been an amazing last 3 years which we have been using. And thanks to Justin for having setting the stage to see how we move with this. And I have nothing to disclose. And today we'll see we'll look a little bit into the workflow for creating a virtual reality or an augmented reality case. We will both, and we'll see some cardiac applications of VR. We use at this point. Last year we've been using exclusively for cardiac applications because we have the champion interventional cardiologist who has a great interest in extended reality. Then we'll see the armamentarium, which we have been used at our facility to set up this process. We have seen that AR and VR are enabling technologies for innovative diagnostic treatment planning with applications and ranging from surgery to visualization and to therapy as well. We have used that for pain treatment as well. And then we have, it also enhances the patient experiences and it improves medical training. The Heart Center Extended Reality Program was started by Dr. Saravidavar about 3 years ago, and we collaborated with them because radiology being the starting point for any imaging, and since we are part of radiology, we were able to coordinate the whole thing and give them from end-to-end solutions for what we do. So when we look at the workflow, we use both CT and MR, and here we'll see a patient with who has a PDA, a complex PDA. If we have a CT done, and then with the imaging, from there we do a 3D reconstruction, and then we will. Here we see how this is a complex PDA from the PA to the aortic arch, and then we transfer these STLs over to the program which we have as Elucys, which uses it with an Oculus Quest or Valve Index right now. So when we use these things, we upload for them, and eventually it's a cardiologist who uses both the Elucys as well as the HoloLens. The HoloLens is basically used for patient education, but the Elucys and the EcoPixel both are used for team discussions and surgical planning and pre-procedural planning, as we will see. The applications we have used will see the understanding of complex anatomy, like at DORV, and then some team discussion and procedural planning and patient education. So here, this is the way we create. This is a DORV patient where you see the double arched right ventricle. This patient also has a tetralogy of Fallot, so it's TOF and DORV. And once we put this, they're able to like sort of switch on and off parts, make certain parts visible. And the best thing for this is they're able to see it along with the imaging itself, and they can use any plane to cut through the models to visualize it better and understand the anatomy. Here, this is the whole heart where you see both things. This one. So next we see how for The programs are also used for interdisciplinary management discussions. For our weekly conferences, this is the routine. And sometimes we have the radiologist and the cardiologist sitting in different spaces and where they're able to react or interact with each other to plan to understand the anatomy and plan the procedures. Yeah, this is a stent planning which we did for sinus venosus. So we actually take the anatomy from the blood pool and then we create different types of stents and then we are able to insert it into the elusive program. And then we are able to evaluate and see which probably works better and take measurements and tools off of it to make the treatment protocol. Here we see how we use augmented reality for patient and family education. Then we see how we take the different parts of the anatomy, we tell them how we restructure the whole anatomy, what happens, and how the parent or the family, they are able to pick it up from there and then work along with the surgeon and understand things better. So here we see how they're going to make the cut and then what's the problem there when there's a constriction, how it's been treated. So here this is another patient, where 34-year-old patient who had surgery performed from end-to-end anastomosis, and then but he we can see there's a recoarctation that happened because it was done in childhood. And now here we see how we design a stent. So these stents are designed in our lab and it's given to the cardiologist where they place the stent and then they are able to move it over. And then you see how they are able to bring it in and they're able to make a trial to see where it goes and what's the sizing and how the stent fits within the space. So now they're able to use different planes and they're able to cut through to see as they walk into it. So once he is satisfied, he changes the position and then make sure everything is according to what he needs. We use our specific CAD programs to design these steps. So this is the next one. This is another sinus venosus, superior sinus venosus, which is there on the SVC. And so here again we see how we also these virtual stents are made from the actual stent design, where we CT the stents and then we keep them at different sizes. And then they're able to bring it in and see and make sure that they're using the right size of the stent. So we have different sizes of stents, which we have them as an STL file as standard stents, and then they able to use that and do that. This is a 4D data where they be able to see the transcatheter for pulmonary valve placement. And so we use 4D CT data or MR data with the function analysis. And then they're able to put it in and see. And the best part is they can manipulate much ahead of the time they go into the OR or the cath lab, and interventionists use it all the time, and our surgeons also use it for basically for understanding of the complex anatomy. So here we see we have two different people, both radiologists and the the cardiologists, they're interacting together, they're taking measurements, and then it's really a very powerful tool. And then what they have to do is how they are planning the PDA is really very interesting for us to see. So with all this, is that in the immersive technology going to replace 3D printing? Probably not. Because the surgeons are very uh, haptic. We really want to touch and see and feel. So we do a lot of prints as an adjunct. So we have different augmentators which serve different purposes. Sometimes we do both. Even after doing the virtual reconstruction and playing around with it, they still want to have a feel to touch and see. So we do a lot of prints. Over the past 8 years, we've done close to about 2,800 or 3,000 models over time. And it's interesting to see how they really want to have, they want to measure in real time. So one challenge which VR has is, though it gives a real, you can take measurements off of it, but when you zoom it up so big, my little constraint will be like when they go and see in real time the size, how they perceive the difference is a great art for them to understand. So the haptic glove is something which is the future technology, or it's just being adapted by some, and we see how it's being used here for interventional procedures. I have not much of personal experience, but I believe our interventional cardiologist does. He did experiences and was using it as part of training program. Technology is really growing every day and every moment, and we see that how we need to adapt to technology to make it to make the best use of what we use. Our setup for the immersive reality is we have used it for the past 3 years, and we have made more than about 150 to 160 cases. And currently, we use it between the cardiology and radiology because it was started by the interventional cardiology program. But now we have licenses to extend it to the rest of the hospital as well. Having understood the benefit of it, especially I'm thinking by next year we'll start using it. We are in the process of setting up across the board. So our skull-based surgeons, our neurosurgeons, and our orthopedic surgeons working on the spine, and our craniomaxillofacial surgeons, they'll all be able to benefit out of it. We use uses for virtual reality. We use EcoPixel for basically for um, again another virtual reality and augmented reality. And for mixed reality, we use EcoPixel. And Epoclar is basically used for the that's mostly only for patients' education, because it does not carry the the imaging data along with it. Whereas the other two, the Eleusis and EcoPixel, it carries the data along with it. So you can have a connectivity with the imaging as well. Last but not least, I would definitely thank Dr. Salavedavar and his team for starting this new technology about 3 years ago, and the Department of Radiology and Leadership for having got us all the necessary tools for for playing. It's been an amazing time. And PAIR is the Pediatric Advanced Imaging resource, which is part of radiology, where who help us with supporting all of our programs and our 3 lab team. This is in short my presentation, and thank you all for the very patient listening. I'll be more than happy to take any questions.
Fantastic, thank you. We do have a question from the audience. It says, I was wondering if there are any requirements or limitations regarding the polygon density of STL models used in the VR environment to ensure a smooth experience in VR AR. Additionally, is the visualization platform standalone or does it require a connection to a workstation?
These are basically standalone systems which we have, but I think there is a possibility for connectivity. I'm not really sure, but as such, we have only individual stations. And as far as the STL goes, we usually use an optimal one, and whenever the number of polygons are less, definitely it is going to tell on the quality of the 3D model for sure.
Perfect. If anyone has any other questions, go ahead and add it in. I did have one question about the haptic gloves. What are the feedback on that right now? I guess both physical and what they're saying. How good are they?
Have not much of experience. It is it's an input from the interventional cardiologist. He's excited to use it, particularly for training purposes,
Okay. Awesome.
for simulation and training. But for it to come on a clinical level with patients' work, it might take some time.
Thank you.